today, about 46% of the requirement of power comes from the renewable sector. There are very stiff targets set by Government of India and even worldwide to triple the capacity of renewable generation by 2030. And we will have about 500 gigawatt of power by 2030. And similarly, it is the same range, maybe around 1130 or something is the capacity today. It has to be tripled worldwide also. And the purpose is to reduce our dependence on fossil fuels and to take us to net zero by 2050. And this decarbonization targets, what we are trying to achieve, the process is not very simple. There are challenges. When we are adding renewable power to the grid stability is sort of lost to some extent. And the problem is that these renewable stations, whether it is wind station or a solar station, they are coming at remote locations where the SCR ratios are poor, the inertia is poor, and grid is weak. And whenever there is a fault, voltage is not restored in time, the fault is not cleared also in time, and fixed capacitor banks or even automatic capacitor banks, which are not capable of meeting the LVRT and HVRT requirements. And so the systems go out of generation. And there have been massive trippings in the year 2022, more than 28, particularly in the area of Rajasthan. So what was decided is just adding the capacity connecting to the grid is not enough. We have to see that it is workable, it is sustainable, it remains in the system. So what was done is a CEA mandated use of static war generators to provide instant reactive power support and to save the situation, to clear the fault in time and to save the grid. So this 33% of the plant capacity has to be taken by the SVGs now. And this is a reactive power compensation or maintaining the voltage level is one challenge. But there is another challenge also, which is we call power quality challenge. These renewable plants, they have a typical harmonic levels. Normally, we find lower order harmonics, and harmonics, so far we knew that they are generated by the loads only. And earlier, the impression was that the generation, transmission, distribution, utilization, all these sectors were very clean and they did not contribute any harmonics to the system. Increasing penetration of RE, the scenario has changed. These plants, they also contribute harmonics to the system. And they don't just contribute simple harmonics like we have from the loads. They contribute complex harmonics. The harmonics are, in addition to the lower order harmonics, we have higher order harmonics up to 49th level. And mitigation of these harmonics is not the standard solutions what we used to have. We have to have different solutions. And it could be passive solution, it could be active solution. Active solution have a limitation that they cater mainly up to 13th harmonic and in some cases up to 23rd harmonic. But passive solutions we can design and they can take care of harmonics of even up to 49th order. And there it is not a simple LC detuned filter. There is also a third component which we call damping resistor. That takes care of the higher order harmonics. So it is a high pass filter we call. So that is a challenge, and CEA has been very proactive. They have mandated that not only the reactive power compensation, the reactive power support is required when they are seeking permission to integrate with the grid, but also the harmonic mitigation norms have to be as per IEEE 519 norms. They have to put in place filters, whether it is passive filter, whether it is active filter, or it is hybrid one. In fact, these things were delaying the projects. So CA had formed a committee, even I was member of that. So we suggested some standard solutions where without detailed studies also we could put something and save the time. And the fine corrections could be done later on. So this 𝗖𝗏𝗏 studies, what were made, the grid parameters, what were available, they were not, you can say, in line with the proper design. So this problem was taken care, and now the things are, whenever the plant is integrated with the grid, the harmonic systems, harmonic mitigation systems are present, and the reactive power management systems are also available in the system. And the power quality, this is a changing scenario. It is not only this RE power is coming into picture. The load patterns are also changing. Today, the majority of the incoming load, the additional loads are coming from AI sector, cryptocurrency sector, and these are data centers, and these are highly harmonic loads. So they have to be taken care at their own level also. So to see that the systems are in a normal condition, they work without issues, without problems. So we have to have that power quality and reactive power management has to be in place. We are increasing the penetration of RE power, but and this is going to keep on increasing only, and one day we will take over the thermal generation. Maybe this will be higher than the thermal generation available. But the growing demand is such that this process may not be as simple as we thought, because the grid stability is provided by the conventional plants only. These RE plants, they uh, are not stable. They are not coming with grid forming inverters so far. Now, maybe certain things have been started, and some of the plants, or maybe many plants, may come with the grid forming inverters, maybe battery backup. And so the things could become slightly more stable, but the real stability, real inertia comes from the thermal plants. And the demand is increasing. And if we keep relying only on the RE power, we may not be able to manage the situation. So government has given a projected demand of 80 gigawatt of thermal power by 2031. So all these major players, Adani's, JSW, or all other maybe public sector players, Coal India and all, they have all lined up the thermal plants also. And these thermal plants also will be filling the stopgap arrangement, and they are helpful in stabilizing the grid. They are helpful in providing the base load demand. They are helpful in providing the peak demand also. So this system will parallelly run for some time till we have a 24/7 reliable RE power. We may have to keep our dependence on with the thermal stations as well. So this is the scenario which is emerging, and it is quite challenging. CA has been very tough, and they are not allowing any systems to be commissioned or to be integrated with the plant unless these requirements of reactive power and requirements of harmonic mitigation are met. They are conducting software studies. They are conducting the simulations. First, you have to show that the simulation is as per the requirements. All the equipments, they are IEEE tested. CA has its own benchmarking process. They have made their own guidelines. Then again, CTUIL has also added certain own conditions of their own. And every division has certain special checks and measures to be done before these things are integrated with the system. So all these things are happening in a very coordinated manner, a very systematic manner, and things are going in the right direction, and people are very proactive, and we hope that we will be able to uh, go for the net zero. We will be able to manage this reactive power growth and have a clean power. uh, Maybe whatever targets we have set could be, we are on, you can say, on the target only. The things are happening as per our expectations, as per our design. And very soon we will have a renewable power dominating the conventional thermal power. Thermal power, as I said, the old plants are discontinued, but new plants are also coming, so that we have some parallel of, you can say, systems available till the time we are fully reliant, fully able to manage with the RE power. And as I said, the harmonics here are very tough. These requirements of maintaining reactive power balance is also, to maintain voltage, is very tough. Within 5 milliseconds, the SVGs have to respond, and these things are there in place, and they have been performing well. And I think and maybe along with China, I think China and India are adding the maximum capacities to the system, and we will be in a position to, uh, you can say, achieve our goals. And we are not at a disadvantage with any even advanced economies like Australia or something. We are doing our job to the best of our capabilities, and into the best international standards things are happening. And we have our consultants who are good at conducting the system studies, simulation studies, and we have our engineers who are able to manage the show, and things are taking place in the right direction.